Okay, do we have a net control on frequency?
I got an email, Carol, from Wilson that he won't be able to make the net tonight.
Okay, that's fine. Thank you very much. This is KP4MD, and I will go ahead and let's see if I can locate that. Just one moment here.
AI 6AG, standing by.
Well, it looks like the link to the control script, the net control script, is not there anymore. We had an update to the website, and that something has to be that link has to be fixed. Anyway, we'll go ahead and start. This is Kilo Papa 4 Mike Delta. My name is Carol here in Citrus Heights, California, and this is the River City Arcs single sideband TV net that we meet every Wednesday at 9 p.m. Pacific time on 441.30 megahertz repeater in the Sacramento area. And also we live stream on our YouTube channel for the River City Amateur Radio Communications Society, which is N6NA. So this is a training net for transmission of images and sound card modes. And all are welcome to join in. And we'll go ahead and take check-ins. Any check-ins, please come now.
Alpha N6 Delta Golf, Joel in Florence.
Okay, we have Alpha India 6 Delta Golf, Joel and Florin. Any other check-ins?
K3REH, Folsom, Anders.
Okay, K3, could I have the last three again of your call sign, Anders, over?
Kilo 3 Romeo Echo Hotel.
Okay, very good, Anders. K3REH, Anders, got you. Who's the next check-in, please? Okay, so we have two check-ins, Alpha India 6 Delta Golf, Joel, and Kilo 3 Romeo Echo Hotel, Anders. We'll go ahead and proceed. 1, 2, and 3. And Joel, if you have a picture ready to send, can you please go ahead? And it's over to you.
PD 120.
Okay, I had a nice clear picture over here. I'll turn over to Anders and see what you have to report on your reception. Go ahead, please, Anders.
I have an excellent reception. For the first time, I'm seeing a little bit of a skew or a shift. It's something I've heard you guys talk about every now and then, that there is some kind of skew where the image needs to be resynced or vertically reset somehow. I see a little bit of that in this picture, so maybe something's going on with my computer. Don't know. But the picture overall, very clear. Got a few pops, not much. The theme is still Niagara, clearly. I recognize that little boat down there. Maybe it's the same one that we've seen on previous pictures, but clearly a wet day, like it probably is most of the time in that region, and a little bit of a lens flare or a rainbow effect there, going from almost the center of the picture and down in an arc around the boat there. So very nice picture. Looks like an awesome view. K3REH, back to net.
Okay, this is KP4MD, and we also have a comment here from Craig on YouTube chat. It says, looks like the Horseshoe and American Falls at Niagara, Canada. And it's nice for Craig to join us there from Cajun country down in Louisiana. Awesome seeing you. Well, I saw the good picture here too. It's nice and clear. I have automatic sync on my SSTV. You right-click inside the picture there, and you can activate auto sync. So if there's any twist or slant, it takes care of that. But beautiful picture. I could see looks like a little boat there at the falls. I don't know if that's a collage. I mean, what do you call a Photoshop, or if that's actually the case, where you have that boat there so close to the what they call the cataract there, the water falling like that. It looks like it would be a lot of turbulence for that boat to be close to. And there's a nice arc of a rainbow that you could see, like 1/4 of a rainbow there, or 1/4 of a circle at least. So, and then there's a bridge in the distance there. I guess that's some bridge that's connecting maybe Canada and the United States. I have no idea. I don't know about the geography there. So we'll turn it over to Joel and have him give us an explanation of this. Back to you, Joel.
So as already been stated, this is Niagara Falls. The boat down there is not a little boat. It's a sizable boat, but the entire object of Maid of the Mist is you get on these boats and you get a nice cruise for a very short distance on the Niagara River below the falls, and they just rev up their engines and get as close as they can safely to the bottom of the falls. And this may look close, but I think they get a little bit closer, but I'm not sure how much closer. Actually, it's been a long time since I saw this, so I don't remember. But those engines are revving. I mean, there's a lot of water coming down the falls. So this is taken from Table Rock, which is at one end of Horseshoe Falls on the Canadian side. In front of you on the Horseshoe Falls starts a little bit to my right and goes kind of a horseshoe shape and around, and you can see the other end of the horseshoe in the middle on the far side of the Niagara Falls Gorge. And that other side is actually on a little island, and it's on the American side. So all the land that you see in the center is an American side. The bridge that you see on the upper left is the Rainbow Bridge that crosses between the American and Canadian side. So the only part of Canada that you see is that railing at the lower left, and the left side of the bridge on the upper left. And the American side that you see up in the center is actually a little island called Goat Island. They've got some bridges that cross over to it, and there's touristy stuff over there. American Falls and Luna Falls is the falls that's in the upper left. And it's hard to describe just how loud this is. You can hear these rapids. The rapids, there's a lot of rapids above the falls, and between the rapids and the waterfalls themselves, you can hear this from quite some distance away. If you're in a convertible driving in, you'll see it. Another thing that you can see for quite some distance, let me let it dry. Another thing that you can see for quite some distance is all this water going down. It creates a little wind, a significant amount of wind and a lot of mist. And the mist goes up. So it's like this permanent cloud. You don't really see too much of it in this picture. But there are times when you can see miles away where the falls are from this plume of mist that's going straight up. And it's actually also a side effect. In summer, everything downwind from wherever the mist is drenched in water because the mist does eventually come down. And in winter, it turns to ice. So things get covered in very thick layers of ice. I've actually got a picture right near where this picture was taken from of one of the lamp posts on the Canadian side, where between the wind and the mist, the water coming down and it freezing, you've got these really weird sideways stalactites of ice coming off of the lamp. And yeah, it's very interesting in winter. You're mucking around taking pictures, the mist is coming down, it's freezing on you. And at the end of one day, as I was walking back towards the bridge to cross back into America, I wondered what the crinkling sound was. And it turned out to be the ice frozen on my jacket that was crinkling against itself as I moved the jacket, and the ice was rubbing against ice. Back to net, AI6DG.
Okay, I think you stopped talking. Wasn't quite sure if you had turned it over to us. But yeah, thank you for that description. Are there any further questions about this picture? No, no other questions. Well, thank you for sharing that. And my question for you, have you ever been to Niagara Falls, Joel? Over.
Oh, yes, that's the picture I took. I spent 6 months in Niagara Falls for work. So I spent part of fall, part of spring, and an entire winter. And took lots of pictures. Got to know the area pretty well. Although that was so long ago, and I know it's changed tremendously on both sides of the border.
Okay, thank you very much for sharing that. I'd be quite interested in the geology of that. There you could see like there's a complete separate heights of different parts of different areas there, as if it was some kind of escarpment or some. I don't think there's a fault going there, but it's quite interesting to see those kinds of geologic formations. Good. So let's go ahead and go over to Anders, K3RH. Why don't you go ahead if you have a picture ready? Over.
I do have a picture ready, and this will be in PD 120.
Okay, this is KP4MD, and I'm looking at the picture that I see there. It looks SWR Freak Picker Upper the K3RH. So this is a original board that you designed, and yep, it does look the board in the front I could see has um, uh, a toroid core with some windings over. It looks like a piece of coaxial cable, which is the kind of pickup that you normally use for forward and reflected power. And it looks like there's two. Okay, there are coaxial connectors on either side of that pickup. I could see just 4 screws holding each one to the board. And see what else I can see. There's a number of components soldered. Um, can't really tell what they are, but and then there's a couple of the blue things that are sticking up. Those rectangular things are multi-turn trim pots. I recognize those. So let's see. In radio, I see that label of on the board in the back there, and then let's see if I can read the rest of the stuff there. Now it's kind of at an angle, and it looks like it's upside down. Those 1, 2, 3, 4, 5, 6 little pads there that are probably the ones that go on the header. So interesting. Over to you, Joel, and see what you make of that. AI6TG. This is KP4MD.
You did an excellent explanation. So we've got an unpopulated board in the background with a schematic behind that, and the populated board kind of in the foreground. Bottom quarter line of the image, I see kind of a bar where the repeater ID. I'm just kind of looking at this. So we've got the two SOs on the background, on the back side of the board, and at the top we got a bunch of the components. I'm assuming not all of them, and the winding of the toroid. And that's what I'm looking at. Is that coax, or is it just a piece of bare wire with an insulator of some kind on it, or is it maybe coax with the shield stripped off? Because I don't see any sign that there's a shield there. Anyway, the toroids, the nemesis of a kit builder. So I'm kind of curious about that. I mean, most SWR power meters I've seen have, or at least in the rigs that I've seen or built, had two separate windings or pickups, one for the forward, one for the reverse. So this is kind of a cute design where you combined it into one. So yeah, an interesting project, and I'm curious how it turns out for you. Is it raw voltages that come off the connector, and you just got to do a analog to digital conversion to get the numbers, then calculate the SWR? Back to net, AI6TG.
Yeah, okay, Anders, could you possibly answer the question if you copied that over?
Yes, this is K3REH, and yeah, this is my little project to make my own SWR power meter. The reason I'm going this route is because I'm building this portable box. I wouldn't say it's portable, maybe a big word, maybe more movable. It's a box that I can easily unload from the back of the car and carry maybe 50 yards in some direction and set up. But in there, I am I have a little bit of space constraint with everything that's going to go in there with battery and power supply and tuner and radio and so on. So and a proper meter was one of the things that I figured maybe I can make it smaller. So I started this project with basically a board, which you see in front of you, which will act as a pickup for the forward and reverse power. And in addition to that, it's also actually a frequency counter, so it's picking up the frequency and dividing it down and providing that as a square wave on one of the pins that goes out. It is correct that the output of this board is just an analog voltage, or two analog voltages, one for the forward and one for the reverse power. So this will connect to a second board, which is a CPU board, short break. And the CPU board will simply have an A to D or a couple of A to D converters to pick up those voltages and convert them into power, respectively, and also calculate the SWR at the same time. The same CPU board is also going to connect to a GPS, so that way I get location and I get a proper time, and figured that that's going to show me both UTC and local time at the same time. And then a few more A to Ds to show battery voltages, show the current draw of the box, and so on. So just a way to kind of compress everything together and make it smaller and put everything on one little touch screen in front of my little Go box. That's what this is going to be, hopefully, if it's working. Right now, this is about as far as I got. I assembled this board, I believe, during the weekend or Friday, and I just got the toroid, so that winding there is brand new. I just added that, and the conductor in the middle is the centerpiece of a coax. That's what the instructions said, that would be a good way to do this. I found a guy that had used this kind of design with a small toroid and a single toroid, and then this little coax piece in the middle to conduct the RF going from one to the other SO connector there. So that's what this is. Hope it came through okay, and K3REH, back to net.
Okay, thank you very much, Anders. Any further questions about this project that Anders is building? Okay, nothing heard. We'll take a standby. Do we have any additional check-ins for the River City Arcs net? This is Kilo Papa 4 Mike Delta. This is the Slow Scan TV net. Okay, nothing heard. I want to thank you very much for confirmation that we are streaming audio on this. Very good. I do have a picture. I'm going to go ahead and load in here. And what I need to do is switch over here and load it in. And it's going to go out PD120. Here we go. Okay, this is KP4MD. We're going to go up to Joel, AI6DG. Can you tell us how you copied that? Over.
Excellent reception. I'm trying to figure out what software it is. So we're looking at a window of some program running. Up on top it says Spectrum version, what is it, 2, build some number, audio source, and then a path to a wave file. So this is C users, Carol music, maybe harp down below. So we've got a spectrum display at the top and a waterfall below that. It's labeled as moon bounce with 3.5 hertz Doppler shift, and on the right side with a bunch of arrows pointing at the water, a line on the waterfall, and harp on the left, right side with arrows pointing to the waterfall in the center. Trying to look at the scale. What is it? 795. So it's like 796. It's the center line that gets kind of turning on and off over time with the waterfall. Oh, it looks like there was a repeater ID in the middle of the screen. I'm not really sure what I'm looking at. Harp. Okay, so that was that ionosphere testing site up at Alaska that got, has it been decommissioned or did it get a reprieve? Basically sending RF into the ionosphere and seeing what it does, I guess. So I guess they were running and this is you picking it up, but when was this, or is it, did they reprieve it and it's running again? Anyway, so there's obviously lots of a story here. What it is, when it is, how to read what we're seeing. So I'm looking forward. Back to net, AI6DG.
Okay, thank you very much for that, Joel. And over to you, Anders. Kilo 3, Romeo Echo Hotel. How did you copy this? Over.
I copied a good picture, some blur, but that's mostly because of the resolution, I think. I think I can see the date up top. It says 11/14/2021, 10:53:51 maybe, and then the horizontal frequency scale there looks like it's around the upper 700s or 795 hertz, so that's obviously in the audio spectra. So this is an audio signal that we're looking at. Peak at 794.88 hertz, maybe. Could that be what it says up in the spectrum part of the thing? Yeah, this is interesting. Why? What are we really looking at? Looking forward to hear the story. K3REH, back to net.
Okay, yeah, this is KP4MD. This is an old test that HARP. The HARP is the High Frequency Active Auroral Research Program, which is up in Gakona, Alaska. It used to be during the Cold War a site for an over-the-horizon HF radar, but it's been taken over by the University of Alaska when the United States Air Force defunded it. And it's a large steerable array of antennas. It operates anywhere from 2.8 up to 10 megahertz. So this is high frequencies, and it's essentially being used right now. It's not being used continuously, of course, because it consumes an awful lot of electricity. They have a total of 3.6 megawatts of transmitter power that they can feed into those antennas. There's actually 100. I'm reading a report that I made on this. There was 180 towers, 12 rows of 15 columns, and it gives you a theoretical maximum gain of 31 dB on HF. What they were doing with this test, it was at the bottom of the last solar cycle, when in the nighttime, in the middle of winter, the ionosphere was the F layer was essentially transparent, and they wanted to do an HF moon bounce test where they were transmitting all that power into this antenna array, and by phasing all of these towers, they were focusing the beam directly towards the moon with an effective radiated power of 3.9 terawatts. That's 3,900 megawatts effective radiated power towards the moon. And it was one of the early citizen scientists experiments they were doing. Let me let the repeater drop a moment. And the idea was they did have an actual research site that was receiving the signals, which was down at the University of New Mexico, the long wavelength array. They were taking some very accurate results over there. But they also opened it up to anybody with a shortwave receiver, saying that anybody with a standard shortwave receiver would be able to receive these signals and make recordings. And what they were doing was they were putting out transmission of a continuous wave of 2 seconds duration, and then they turned it off for 2 seconds. And it was timed exactly so that the 2 second transmission would travel to the moon, come back, and you would hear the echo in the 2 second period that it was off. And of course, that's based on the distance between the Earth and the moon. So they wanted to show that it was possible to receive lunar echoes on a standard shortwave receiver. So they were asking people to make recordings, audio recordings, and to send them in. Yeah, this is a audio recording that I made back in 2008. It was, I believe, January of 2008 on a Kenwood receiver using a random wire antenna that I had at that time, which was the only HF antenna I had up. And the signal that was coming in from HARP, actually I was getting some ionospheric scatter. I mean, there's this tremendous amount of power, even with very poor ionospheric propagation. There was enough scatter that I was getting signal that was S9 on the ionospheric scatter. What was coming back from the lunar echoes there that you could see highlighted there were thinner because they were lower amplitude, and they measured about 5 decibels above the noise level. And there was that Doppler. There was a shift you could see there, and it came out to about 3.5 hertz. And the explanation for that was the moon was actually in orbit, and it was actively moving away from the transmit and receive stations, so it exhibited a Doppler shift. And like as you said, this was an audio file. It was captured on a computer as a waveform, feeding it through this program called Spectran. Drop one more time. Spectran is a freeware program that you can do analysis of audio signals. So with you get a spectrum and also a wave, a waterfall. So it was a way for just common people to be able to participate in a little scientific experiment. They requested if you captured a wave file to go ahead and send it in, and they would then send you a QSL card, which I did get, and I thought that was kind of fun. So that was HARP. And I know there's a lot of conspiracy theory going around about HARP, that people were saying it was being used to control the weather or to control people's minds and stuff, but that's all nonsense. It's just studying of the ionosphere, the upper layers of the atmosphere. Any questions about this, KP4MD?
What part of the display reflects the Doppler shift? Is the dark bands in the center the reflection from the initial transmission?
Okay, yeah. There's actually there's a little bit of ringing in the when I was doing this analysis. I had what they call the rate of uh, oh my gosh. There's I'm at a loss for words right now. But the way you set the resolution on the bins where you're the different frequency bins when you're doing the analysis there, it's a Fourier transform. If you go down to a very tight resolution, you get a little bit of ringing, and so it looks like the time of the segments are actually overlapping, but it's not true. The heavy, dark, bright, I'm sorry, the bright white segments there are the signal that is being scattered by the ionosphere. It's what I was getting directly from the HARP transmitter scattering in the ionosphere, so it was the most direct signal I was getting from the Alaska. The thin segments to the left actually were heard in between the 2-second transmissions from Alaska, and those were the weaker lunar echoes. Over.
Okay, and the Doppler shift is reflected in the fact that they're not directly on top of the bright thing in the center. They've been shifted down. So the Doppler shift was a minus 3.5 hertz.
Yeah, that is correct. That is correct because as I was using upper sideband, so a lower audio frequency would mean that the signal is shifted downwards by 3.5 hertz. And you should be able to make a calculation. I guess it's not straightforward, as far as velocity, because it's not a direct velocity away from the stations. There's a little bit of angular. You'd have to find out what the angle was to the moon from the receiving station and the transmitting station in order to calculate the exact velocity of the moon. Over.
Is that 3.5 hertz a typical EME amount of Doppler shift?
Well, if I remember correctly, the Doppler shift varies depending. If the moon is moving towards you, it's going to come positive. It's kind of when you're at the end, what they call the acquisition of signal and the loss of signal. The moon is kind of moving more at a tangent, so you don't get a very you do get a shift there that's kind of maximum one way or the other. Yeah, you have a maximum negative shift at the end of signal, and then you also have a maximum at the acquisition of signal. And when the moon is directly overhead, if it is directly overhead, it kind of slows down. There's not so much of a shift there. Over.
So the Doppler shift is due to the rotation of the Earth. So if it's on one horizon, it's going to be plus. If it's on the other horizon, it's going to be minus.
Yeah, and of course the moon is actively moving. It's actually moving as well. So it's a combination of the rotation of the Earth and the movement of the moon. So it's a little bit complex. Over.
Roger that. Interesting. This is something else to get into sometime. EME and all these little points, like of which this Doppler shift is just one of them. But usually you think Doppler shift on satellites, but I guess that's what the moon is. It's just a very big, much further away satellite.
Yeah, this was quite an interesting experiment. I have never really tried actually doing moon bounce myself on VHF or UHF. I'm kind of limited as far as antennas go here. Although I heard that even with JT65, you can do it with a simple Yagi that's tracking the moon. But this was a chance for me to do it with just a regular random wire and a shortwave radio. Over.
Roger that. Thank you for the picture and the explanation. Back to Net AI6TG.
Okay, so well, we've had one complete round here, and it's already 9:45. We're going to see first of all, does anybody have any other pictures they want to share, or maybe we should just close the net at this time?
K3REH, quick comment.
Sure. Go ahead, Anders.
So I did quickly Google here about the moon Doppler shift. It's interesting that I gotta draw this in front of me to figure it out. But the shift actually changes with the carrier frequency. So they say here that the Doppler shift can be as much as plus minus 440 hertz at 144 megahertz, and if you go up to 1.2 megahertz carrier, then it's plus or minus 4 kilohertz. So not exactly sure how that works. I think I need a whiteboard to figure that out. But very interesting stuff. K3RH, back to net.
Absolutely, yeah, and this is of course 7 megahertz. The Doppler shift is going to be minuscule compared to what you have up at the microwaves. So, but it is detectable, and it's too fine to hear with the human ear alone. But doing this kind of analysis with the Spectran, you can very clearly measure it there. So I thought that was quite interesting. So nothing further here. We're going to go ahead and secure the net if nobody else has another picture to share. One final call. This is KP for MD. Okay, nothing heard. Well, I want to thank everyone for sharing your pictures today, and a very interesting discussion. And we got the recording right this time. Last week I did something wrong, and we missed about the first half of the net on the YouTube stream. Anyhow, want to thank everyone again, and we're going to say 7-3, and we will secure the Slow Scan TV Net, and we'll be back here again next week, same time, Thursday at Wednesday. I don't know, I'm thinking Thursday. Wednesday at 9 p.m. Pacific time. This is Kilo Papa 4 Mike Delta saying 7-3s and good night to all.